Hello students, once again welcome you to GK's maths classes. Today we are going to again continue with the continuity and differentiability. This is a part 3 of the video. Already in part 1 we have given you introduction of what a continuous function is and we have solved some problems, and in part 2 also we have did around 10 questions. So today I am going to do few more problems in continuity. Some of them are from the NCERT book and some of them are board questions. So I hope this video will be useful to you. So straight away let's get inside the problems. Actually what I'm going to do is I'm not going to explain the concept again. I will put the link of the part 1 in this video in the description box, so that if you have any doubt regarding the introduction you can always look into it. Okay. But just to brush up, I'll just tell you the formula so that it's required for us. Now what you will say, since the function is continuous, or you can say the function is continuous at x is equal to a. When is it continuous? If limit x approaches to a, f of x exists, if the limit exists, and if f of a exists and both are equal, the three conditions should be satisfied. So if all these three conditions are satisfied, you can conveniently say the function is continuous. Now when you say limit exists, when LHL is equal to RHL. Okay. So in course of the problem we'll see how to go about it. Okay. Let's go to the first question. Now here the question is, find a and b if this given function is continuous. Here if you notice carefully, they have not told you where the function is continuous. So if they don't mention where the function is continuous, it is understood that the function is continuous in the entire real line. Okay, the function does not have any point of discontinuity, right? But I am not interested in the entire real line. I am only interested in 2 points. What are the 2 points that I am interested in? I am interested in x is equal to 2 and I am interested in x is equal to 10. Now why am I interested only in these 2 points? Because that is where you are having two different functions. See, x less than 2 you have 5, x greater than 2 you have ax plus b, two different functions. Similarly, when x is less than 10 you have one function, for x greater than 10 you have another function. So that is why since the two functions are different, I want to know whether anything happens there. Okay, so let's see. Now nothing happens because it's already given the function is continuous. So definitely my LHL will be equal to RHL. So what is LHL? Limit x approaches to 2 minus. 2 minus means definitely less than 2. If it is less than 2, I will be using this function, that is 5. And for right hand limit, it will be limit x approaches to 2 plus. 2 plus means x is greater than 2. If x is greater than 2, I will be using this one. So I get ax plus b. And since this is independent of x, the left hand limit is 5. And in the right hand limit, by direct substitution, I get 2a plus b, which is equation number 1. Okay. Now what I will do, I'll go for the left hand limit of limit x approaches to 10 minus. 10 minus means x is less than 10. If x is less than 10, the function is ax plus b, and it is limit x approaches to 10 plus. 10 plus means x is greater than 10. If x is greater than 10, I will be using 21. So on direct substitution, I get 10a plus b equal to 21. So I have got two linear equations. It is very simple to solve them. All that I do is I will do 2 minus 1. 2 minus 1 will be 8a equal to, what is 21 minus 5? 16, I think, right? 16. And what is a equal to? 2. Once you get a equal to 2, substitute here. What do you get? 5 equal to 2a plus b. So b equal to 1. So the value of a is 2 and b is 1. Very simple, straightforward question. What I want you to remember is, he has said the function is continuous. He has not told where it is continuous. That means it is continuous in the entire real line. Okay. Now let's go to the second question. Discuss continuity at x is equal to a. You are having this function. So first of all, let's talk about the left hand limit as usual. Now what is my left hand limit? Limit x approaches to a minus. A minus means definitely less than a. If it is less than a, what is my function? It is x cubed by a square. On direct substitution, I get a cubed by a square. A cubed by a square is nothing but a. So left hand limit is a. Now what is right hand limit? Our right hand limit is limit x approaches to a plus. A plus means x is greater than a. If x is greater than a, I will be using this function. This is 2a minus a cube by x square. So on direct substitution, what do I get? I get 2a minus a cube by a square. So I get 2a minus a, which is nothing but a. So clearly you can see LHL is equal to RHL. So if LHL is equal to RHL, what do you know? Limit x approaches to a, f of x exists. So can I conclude that the function is continuous? Definitely no. Why? Because you know, if a function has to be continuous, it has to satisfy all the three conditions. So just because its limit exists, you cannot conclude the function is continuous. Okay. The reasons I have discussed in video 1 also, you can just have a look at it. Now what is f of a? The next one, f of a. So when x is a, what is f of a? F of a is a itself, right? Now what do you say from these two? Clearly, limit x approaches to a, f of x equal to f of a. This implies what? The function is continuous at x is equal to a. Beautiful, isn't it? Very, very simple question. The sum looks very complicated, but there's nothing in it. Now let's go to the next question. This is a very, very important question. It is one of the board questions. Okay. Now he has said the function is continuous. Where it is continuous? It is continuous at x is equal to pi by 2. Since it is given that the function is continuous, clearly your LHL is equal to RHL is equal to f of a. Okay. So let's go one by one and talk about left hand limit. So what is my left hand limit? My left hand limit will be limit x approaches to pi by 2 minus. Pi by 2 minus. That means definitely less than pi by 2. If it is less than pi by 2, what is my function? 1 minus sine cube x divided by 3 cos square x. Okay. Now how do I evaluate this limit? Very, very simple. This is limit x approaches to pi by 2 minus 1 minus cos cube. You can use a cube minus b cube, which is a minus b into a square plus ab plus b square divided by 3 into, what is cos square x? You know, cos square x is 1 minus sine square x. Correct? So now this is limit x approaches to pi by 2 minus, you have 1 minus sine x into 1 plus sine x plus sine square x divided by 3 into, what is 1 minus sine square x? It's 1 plus sine x into 1 minus a square minus b square. So clearly they get cancelled because when x is not pi by 2, so 1 minus sine x cannot be 0. So when you put x is pi by 2, you get 1 plus sine pi by 2 is 1. So divided by 3 into 1 plus 1. So the answer is 1 by 2. So what is your left hand limit? So my left hand limit is 1 by 2. Let's go to the right hand limit. What is my right hand limit? Now right hand limit will be limit x approaches to pi by 2 plus. Now what is pi by 2 plus? It is definitely greater than pi by 2. So what is my function? B into 1 minus sin x divided by pi minus 2x the whole square. Now how do I evaluate all this? You have studied in 11th standard, so you can understand. I multiply and divide by 1 plus sin x. So when I do that, what do you get? I get limit x approaches to pi by 2 plus b into, what is 1 minus sin x into 1 plus sin x? It is 1 minus sin square x. 1 minus sin square x can be written as cos square x. Then I do one more thing, that from this I take 2 outside. So when I take 2 outside, it already there's a square there. So when you take 2 outside, it will come out as 2 square. So I will get here pi by 2 minus x the whole square. Okay, and what is left out? 1 plus sin x. Okay, now this is limit. Can I say cos square x is, cos is sine 90 minus theta, correct? Divided by pi by 2 minus x the whole square. So they get paired, right? So cos square is sine square 90 minus x. Sine square and whole square, they will become 1. And what is the remaining term? The remaining term is b by 2 square, b by 2 square into 1 plus sin x. So I can split the limit like this. Limit x approaches to pi by 2 plus. Now here you can say x minus pi by 2 approaches to 0. Therefore, pi by 2 minus x will also approach to 0. So it satisfies the formula. So what happens to this? This becomes 1 sin x by x, when x, here my x is pi by 2 minus x. So sin pi by 2 minus x by pi by 2 minus x is 1 whole square, therefore it is 1 square, so it's 1. So when you put x is pi by 2, sin pi by 2 is 1. So 1 plus 1 is 2, so you get b by 8. Correct? Now, since the function is continuous at x is equal to, I'll just copy this and keep, I may need it. Is continuous at x is equal to pi by 2. What do you know? I know that LHL equal to RHL equal to f of pi by 2. Now what is LHL? My LHL is half. And what is my RHL? It's b by 8. And what is f of pi by 2? F of pi by 2 is a. So clearly you get a equal to 1 by 2 and b equal to 4. So very, very simple question. Only thing is this, you definitely have to work very hard on limit. You have to be very careful with that. Okay. I hope this is clear. Now the next question. A very, very beautiful sum. Very simple question, but lot of idea in it. Okay. Now look at this function. Limit. Here I don't have to use left hand limit and right hand limit. You don't have to. If you want to use, you use. You don't have to use because on the left side of 0 and on the right side of 0, I have the same function, the sine of 1 by x. Since to the left side and to the right side I have the same function, I don't have to use LHL and RHL. Okay. So then how do I evaluate this limit? So limit x approaches to 0. Since it is x approaches to 0, x is definitely not equal to 0. Since x is not equal to 0, my function will be sine of 1 by x. When x is not equal to 0, the function is sine of 1 by x. Okay. Now what happens here? Clearly, when x goes to 0, 1 by x goes to infinity. When x goes to 0, 1 by x goes to infinity. But sine of 1 by x will oscillate, okay, will OSI oscillate spilling oscillate between +1 and -1. It will oscillate OSCILET, I think. I don't know, just don't bother. Sine of 1 by x oscillates between +1 and -1. It takes values between +1 and -1. It does not go and stick to a particular value. So you can say clearly, limit x approaches to 0, sine of 1 by x does not exist. The limit does not exist. Why? Sine 1 by x oscillates between +1 and -1. It doesn't go to a particular value, which I would like to show you on GeoGebra. Just give me a second. I'll just draw the graph for you. It is sine of 1 divided by x. Look at the graph. So this is the graph of sine 1 by x. It oscillates between +1 and -1. It does not converge or tend to a particular value. If you want, I can just zoom in and show you. See this? You can see how nicely it comes. See this? If you see, it doesn't tend to a particular value. Since it does not tend to a particular value, since it keeps oscillating between +1 and -1, the limit does not exist. Is it clear? Okay, let's go back to our regular thing. Now, that is why limit does not exist. Therefore, you can say the function is discontinuous at x is equal to 0. Because I don't know what is happening at x near 0. When you go nearer and nearer to 0, it's only keep on oscillating. It doesn't come to a particular value. Okay? Now, let's look at x square cos 1 by x. Now, here also, I don't have to use LHL and RHL because to the left side of 0 and to the right side of 0, I have the same function x square cos 1 by x. Since I have the same function, it is not necessary for me to use LHL and RHL. So I have to just find limit. Now how do I do that? I'll go for limit x approaches to 0, x square cos of 1 by x. X square cos of 1 by x. Now what happens when x approaches to 0? 1 by x will approach to infinity. When x approaches to 0, 1 by x approaches to infinity. But cos 1 by x will approach to some number, I don't know what number, we don't know, it only oscillates. You remember? Just like the previous problem. What is true for sine 1 by x will be true for cos 1 by x. So it only oscillates between a number between +1 and -1. We don't know what number it is, but it will definitely be a number between +1 and -1. Okay, since it's a number, what happens when I say limit x approaches to 0, x square cos 1 by x, it will be 0 because when you put x as 0, you get 0 into some number between +1 and -1. We don't know what number it is. We don't know. Because I told you, right? Cos 1 by x also oscillates between +1 and -1. So it is 0. So limit x approaches to 0, x square cos 1 by x is 0. So limit exists. Whereas sine 1 by x limit did not exist. But for x square cos 1 by x limit do exist. Now what do? You go for f of 0. Now what is f of 0? According to the definition, it is 0. Now clearly you can see limit x approaches to 0, f of x equal to f of 0. This implies the function is continuous at x is equal to 0. Okay. Now as usual we'll just visualize that once and then we can continue. Okay. Just a second, I'll go back to this. Okay. Now see here we talked about sine, right? So I will instead of sine I'll put cos. Okay. Just to make you understand the difference. I'll type cos. It will be exactly the same. It will keep on oscillating between +1 and -1. Cos 1 by x will oscillate between +1 and -1. Now let's go for x square into, right? So it will be x square into so let me write into cos of 1 divided by x. Look at this. See the difference. X square cos 1 by x. If I zoom in, see what happens. If I zoom in, you can see clearly. Just a second. I'm going to zoom in, watch it. So when I zoom in, can you see the graph? It's a very beautiful graph. See the graph. So when I go closer and closer and closer to 0, x square cos 1 by x will slowly tend towards 0. That is why limit exists. So what is limit x approaches to 0, x square cos 1 by x? It is 0. And f of 0 is defined as 0. Therefore, the function is continuous. See, the function is continuous. Whereas, look at this function. Cos 1 by x, it only oscillates between +1 and -1. Limit does not exist at 0. Therefore, the function is discontinuous. Okay. And same is the case for x cos 1 by x. Okay. Let me go back to the page. Actually, this. Even for this, you can try this for as a practice. You can try sine of 1 by x, or you can say x sine 1 by x not equal to 0, 0 when x is equal to 0. Exactly the same argument. Sine 1 by x will oscillate between +1 and -1. 0 into a number between +1 and -1 is 0. Limit will exist. F of 0 exists. Function is continuous. Even if the question is like this, x square sine 1 by x, it's the same thing. Okay, so I'm just giving you all possibility. Okay, so any question, the argument is the same. For sine 1 by x and cos 1 by x, always oscillates between +1 and -1. So 0 into any number, 0 into cos 1 by x will be 0. Okay, let's go to this. Now this is about factorization. Find the value of k. Once again, if you see, to the left side of k and to the right side of k, I have the same function. X not equal to 2 means at 2 we don't know what happens, but to the left side of 2 and to the right side of 2 it's the same function. So I don't have to use LHL and RHL to evaluate the limit. So I just have to do the limit. How do I do? Limit x approaches to 2, x cube plus x square minus 16x plus 20 divided by x minus 2 the whole square. Now definitely if you put x is 2, you get 0 on the numerator. You can test it. So that means x minus 2 is a factor. So there are two ways to do it. Either you can do polynomial division or you can do synthetic division. I prefer to do synthetic division. Now what is synthetic division? Coefficient of x cube. What is coefficient of x cube? It's 1 and x square is 1 and x it is minus 16 and constant 20. Since x is equal to 2 is a factor or x minus 2 is a factor, x is equal to 2 is a root, you start with 2. If it was x plus 2, you will write minus 2. If it is x minus 2, if x minus 2 is a factor, you write 2. If x plus 2 is a factor, you put minus 2. Okay. Now begin with 0. Inside you add, outside you multiply. 1 plus 0 is 1. 2 into 1 is 2. Again add, it's 3. Now multiply, 2 into 3 is 6. You add, minus 10. 2 into minus 10 is minus 20. Definitely you should get 0. That means x minus 2 is a factor. Okay. So you can write this as limit x approaches to 2, x minus 2 into, this is highest power is 3. So 1 power less, x square plus 3x minus 10 divided by x minus 2 the whole square. This can be cancelled. But this is not a great thing because it's a quadratic equation. You know it can be factorized very easily. The factors are x minus 2 and x plus 5. Okay. Minus 2 into 5 is minus 10. So that's how I got it. Splitting the middle term. Okay. Cancel it. What do you get? I get 7. So your limit is 7. Now since the function is continuous, where at x is equal to 2, the limit x approaches to 2 f of x is equal to the functional value. Correct? So, but what is my limit? I have calculated the limit is 7. And what is my f of 2? My f of 2 is k. So it's job done. Correct? Very simple. Let's go to the next question. Find the value of a if f of x is given like this, is continuous. Ask a question, should I use LHL and RHL? Definitely no, because to the left side of 0 and to the right side of 0, it's the same function. Okay, so it's enough to evaluate the limit. How do I evaluate the limit? Limit x approaches to 0, it is actually sine square ax by x square. If it was only sine ax, I would have multiplied and divided by a. But it is sine square ax. So what do? Since it is sine square, okay, I need a square. Can I simply introduce a square? No. So you multiply and divide by a square. Now when x goes to 0, where will ax go to? If you multiply both sides by a, ax also goes to 0. So this satisfies the formula. Limit ax approaches to 0, sine ax by ax is 1. Whole square will make it 1 square. 1 square is 1. So what is my limit? My limit is a square. Now what do? Since the function is continuous, at x is equal to 0, continuous at x is equal to 0, what do you know? Limit x approaches to 0, f of x equal to f of 0. What is my limit? My limit is a square. And what is f of 0? F of 0 is 1. So a will be what? Plus or minus 1. Simple question for 2 marks. Okay? So that I don't use LHL and RHL. Let's go to the next question. Look at this. This is again a question where I don't have to use LHL and RHL. So what do? Limit x approaches to 0, cos square x minus sin square x minus 1 divided by root of x square plus 1 minus 1. Okay. Now what I will do is very simple. It is write this cos square x as 1 minus sin square x. And this will remain as it is. And in the denominator, what you do? Denominator you rationalize. Multiply and divide by x square plus 1 by root of x square plus 1 plus 1. I just rationalize the denominator. Now clearly plus 1 and minus 1 cancels. So what do I get? Limit x approaches to 0. I get sine square x. Of course I get minus 2 sine square x. I'll keep the minus 2 outside. Divided by, what is this? A square minus b square. It will be x square plus 1 minus 1. So effectively it is only x square, correct? And this is limit x approaches to 0, root of x square plus 1 plus 1. Root of x square plus 1 plus 1. This I did not use till now. Now clearly this satisfies the definition of the formula. Limit x approaches to 0, sin x by x is 1. So it will be minus 2 into, when you put x is 0, you get root 1 plus 1, that is 2. So my limit is minus 4. Then what do you write? Since the function is continuous at x is equal to 0, limit x approaches to 0, f of x is equal to f of 0. So what is my limit? My limit is minus 4. And what is my f of 0? My f of 0 is k. So I have found the value of k. That is the question. Find the value of k for which the function is, here it says the function is continuous at x is equal to 0. It is, I think there's a mistake in typing. So find the value of k if this function is continuous at x is equal to 0. No change. Now the next question. Very simple NCERT question. Find the value of k if the function is continuous at x is equal to pi by 2. Very, very simple. Should I use LHL and RHL? The answer is definitely no, because to the left side of pi by 2 and to the right side of pi by 2 I have the same function. Therefore, how do I evaluate the limit? Limit x approaches to pi by 2, k into cos x divided by pi minus 2x, correct? Now this will be limit x approaches to pi by 2. Need to be careful. Can I write cos as sine of 90 minus x? K into sine of 90 minus x, and denominator what I will do, I'll take the 2 outside. When you take 2 outside, what do you get? I get pi by 2 minus x. Okay. Now when x goes to pi by 2, where will x minus pi by 2 go to? It will go to 0, right? I brought it this side. And where will pi by 2 minus x go? Obviously to 0, because multiplying throughout by minus sign. So what happens to this? It satisfies the definition of the limit. Limit x approaches to 0, sine x by x. Here my x is pi by 2 minus x. So my limit is k by 2. Then what do you write? Since the function is continuous, just a second, okay. Since the function is continuous, where at x is pi by 2, my limit, what is my limit? Limit x approaches to pi by 2, f of x is equal to f of pi by 2. Now what is my limit? Limit is k by 2. And what is f of pi by 2? F of pi by 2 is given as 3. So what is k equal to? My k equal to 6. Simple, isn't it? Now let's go to the next question. This is again a very nice sum. Find all points of discontinuity of the function f of t equal to 1 by t square plus t minus 2, where t is given by this. Okay. So if you want the t to exist, definitely x should not be 1. Correct? So first point of discontinuity, is x is 1, because x cannot be 1. Let it be that. Now what do? You take it and substitute here. 1 by t square plus t minus 2. Okay, and this is like f of t. This will be discontinuous if the denominator is 0. The function does not exist if the denominator is 0. So the point of discontinuity will be at t square plus t minus 2 is 0. So what is t square plus t minus 2? It is t plus 2 into t minus 1 equal to 0 by factorizing it. So what do I get from this? T equal to minus 2 and t equal to 1. So when t is minus 2, what is that? It is 1 by x minus 1 equal to minus 2, right? So t is 1 by x minus 1. Now taking reciprocal, x minus 1 equal to minus 1 by 2. So what is x is equal to? 1 minus 1 by 2, which is 1 by 2. So second point of discontinuity is 1 by 2. Correct? Now what is t? 1 by x minus 1 equal to 1. So what is x minus 1? Is 1. So x is equal to minus 2. The third point of discontinuity is minus 2. So there are 3 points of discontinuity. Once again, I'll repeat. This particular function, okay, if you want the t to exist, x should not be 1 because t is defined as 1 by x minus 1. So x cannot be 1. So if at all there is a discontinuity, it will have discontinuity at 1. So this is taken care. Now I go to the main function. This function will not exist if the denominator is 0. This function will not exist when the denominator is 0. So that is the point of discontinuity. So when the denominator is 0, by factorizing, I got t equal to minus 2 and t equal to 1. From that, very clearly, it's very easy to understand x is equal to half and x is equal to minus 2 is the point of discontinuity. Is it clear? Very simple, very effective sum. Now third one. Discuss continuity of the function sine of modulus x. Now in mathematics, there's a result. If f is continuous and g is continuous, then the composition function f circle g and g circle f are continuous. Since we don't have composition of function in our syllabus, I will look at it as f of g of x or g of f of x. Okay, basically they are composition of function. Now, clearly, modulus of x is continuous. Clearly, modulus of x is continuous everywhere. Okay, because you know the graph of modulus x. Modulus of x is continuous, and clearly sin x is also continuous. When I say continuous, it is continuous everywhere in the entire real line. Okay, it is continuous in the entire real line. Now sin and mod x both are continuous means its composition, the composition function sin of mod x is also continuous. Is also continuous. Now you may ask how all these things work. If you want, I can explain this to you. Let us take f of x as modulus of x and g of x as sin x. Now there are two compositions. One is f circle g of x. This is composition. This is defined as, I will not go too much into the detail, I'll just give you as a formula. F circle g of x is given as f of g of x. It is f of g of x. Okay, which is f of, what is g of x? G of x is sin x. Correct? But what is f of x? F of x is mod x. In place of x, what do I have? I have sin. So this is modulus of sin x. So this is one composition that I get. Composition means combining two functions. This is one composition function I get from modulus x and sin x. I can get another one. What is that? G circle f of x. How it is defined as? G of f of x. Okay, which is g of, what is f of x? My f of x is modulus of x. Okay, my f of x is modulus of x. Now look at this. This is g of x is sin x. So in place of x, what do I have? I have modulus x. So wherever x is there, put modulus. So sin of, in place of x, what should come? Modulus x. So if I do composition of mod x and sin x, I get sin of mod x. If you do g circle f, I get sin of mod x. If I do f circle g, I get modulus of sin x. In either case, both are continuous. You have done two problems simultaneously. Sin of mod x is continuous because modulus x is continuous, sin x is continuous. Composition of two continuous functions is continuous. Therefore, sin mod x is continuous. Very, very simple. Okay. Now, I'll do one more result to look at this. Once again, this is mod cos x. So obviously, you know, it's the composition of modulus of x and composition of what? G of x is cos x. So if you do f circle g of x, if you repeat that process, you get modulus of cos x. So clearly, mod x, f of x is equal to mod x is continuous. And g of x, what is g of x? G of x is equal to cos x is continuous, where they are continuous in the real line. Okay. Therefore, the composition of function, what is that? Modulus of cos x is also continuous. It's very, very important you know these results. These are very important for 1 mark questions. Okay. Let's quickly go back and check in GeoGebra. I just want to show you how these functions look like. Okay. Because always you should know the geometry. Now let's delete all those. This is all not required for me. Now what I want to find, I want to check sine of mod x, right? So sine, okay, sine of what? Sorry, sine of mod x, mod on the absolute x. Look at the graph. Sine of mod x. It's perfectly continuous. At mod x, you have this. There is no break in the curve. We are going to talk about differentiability. Definitely, the function is not differentiable at x is equal to 0. It is having a sharp edge. We'll deal with all those things when we do differentiability. But definitely, sine mod x is continuous, but it is not differentiable at 0. Okay. Just for your understanding, I'm telling you. Okay. So we can. I think it should be okay. And you see, it's perfectly continuous. It's a wonderful graph. Now let's also look at modulus of cos x. Okay, ABS. Small letter. ABS. Modulus of what? Modulus of cos x. What is modulus of cos x? Look at the graph. It's perfect. It's perfectly continuous. But it has a lot of points where it is not differentiable. But it is perfectly continuous. Modulus of cos x, there is no break in the curve, so it is perfectly continuous. So mod cos x is continuous. Sine of mod x is continuous. Okay. Now let's go back to the last problem. The last question is, look at this. Now here, for what value of k is the function defined here is continuous at x is equal to 0. Is continuous at x is equal to 0. So here I have to use LHL and RHL because to the left side of 0 and to the right side of 0 I have two different functions. Okay. So what is my LHL? First I talk about 0. Left hand limit. Limit x approaches to 0 minus. What is 0 minus? X is less than 0. Less than 0 means it is k into x square minus 2x. So when I apply the limit, when I put x is equal to 0, so I get 0. So my left hand limit is 0. Now go to the right hand limit. What is right hand limit? Limit x approaches to 0 plus. What is 0 plus? 0 plus is 4x plus 1. So when I put x is 0, I get 1. Now clearly you can see LHL is not equal to RHL. If LHL is not equal to RHL, what do you say? Clearly limit does not exist. Does not exist. If limit does not exist, what do you say? The function is discontinuous at x is equal to 0. But the question is, for what value of k is the function continuous? You can see, you put any value of k, your LHL is going to be 0 and your RHL is going to be 1, limit will not exist, the function will be discontinuous. For any value of k, the function will be discontinuous. So we can say for no value of k, for no value of k, the function will be continuous. If I change the question slightly, for what value of k will the function be discontinuous, means for all real values of k, it will be discontinuous. See, look at the question and answer. For all real values of k, the function will be discontinuous. For no value of k, the function will be continuous. Where? At x is equal to 0. Okay, that finishes the first part. He wants to know what about continuity at x is equal to 1. Now look at this, x is equal to 1. 1 means the 0 is here. So if I come from the left side or from the right side, when I am very close to 1, whether on the left side of 1 or to the right side of 1, I am always greater than 0, right? Whether it is to the left side of 1 or to the right side of 1, my values of x is always greater than 0 because you are very, very close to 1. You have crossed 1 and came when you are coming from the left side. So near 1, my function is always 4x plus 1. So it is not necessary for me to use LHL and RHL. So what do? I straight away go to limit. Limit x approaches to 1. When I say x approaches to 1, definitely x is greater than 0. So what function should I use? 4x plus 1. So direct substitution, you get 5. So limit is 1. Now what is f of 1? F of 1, again you have to substitute here. What do you get? 4 into 1 plus 1, which is also 5. Now what do you say about both? So limit x approaches to 1, f of x equal to f of 1. This implies the function is continuous where? At x is equal to 1. Whereas the function was discontinuous at x is equal to 0, here the function is continuous at x is equal to 1 because 4x plus 1 is a straight line, okay, for greater than 0. So I hope you have understood. With that, we will stop. We will do more problems in the next class, and maybe we will start with differentiability. Okay, thank you very much for watching the video. Kindly subscribe to my channel and also click the bell icon to get notifications on all videos. Okay, have a lovely day. Bye bye. See you in the next class.